are the final year students of Diploma in Mechatronics Engineering in Smart Factory in NTTF Vellore. For our final year project, we have developed an autonomous tri-EV. Our team members are myself, Gokulnath,
myself, Haridhar,
myself, Manibalaji,
myself, Kanish Kumar D,
myself, M. Kishore. And we are going to explore our project now.
The autonomous drive is designed for senior citizens, visitors, examiners, and interviewers who may feel uncomfortable while walking long distance during the campus visit. The main goal of our project is to reduce the visitors' uncomfortable pain during the campus visit. Easy to locate the destination points with user-friendly. Through this project, we have gained a valuable knowledge and hands-on experience in areas such as autonomous navigation, motor control, sensor integration, programming integration, and system design.
I am going to explain about the present system. So, present system we are compared between a e-vehicle and autonomous vehicle. In e-vehicle we are compared between a e-rickshaw and golf car. So, these are the two vehicles we compared between autonomous. The autonomous vehicle are Tesla. So, also many companies are improving in autonomous. So, also we are considering a cost efficiency. The cost efficiency of e-vehicle is coming around 2 to 3 lakhs. So, our main aim to reduce the cost of a vehicle. So, our project cost is 1,10,000. We made this vehicle for our campus environment. So, commonly we are make the 7 destinations. So, when visitor will enter into the vehicle, the display will be automatically on. They will show a destination points. The vehicle, we made this vehicle for our college environment. We have choose 7 destinations in our. So commonly you are entered into they will show 7 destination points. We can select the destinations easily. For safety purpose, we are used the ultrasonic sensor LiDAR. For ultrasonic sensor, we are used 7 ultrasonic sensor in our system. For LiDAR, also we are used for mapping for purpose. We are used the LiDAR, and for these 2 are mainly used for obstacle detections. In case of any malfunction in our system, you can stop the vehicle using an emergency stopper.
Now we are going to explore about the main components in our project. First, a battery. Battery is the main power source of our system. We are using a lead acid battery of a single battery source of 12 volt and 100 Ah. We are connecting as a 4 battery as a series to boost up the voltage to satisfy our system, motors and etc. Next, a mid motor of 48 volt and 1000 watts used to power up the vehicle with the help of a differential. Because of it is an autonomous, we need to control the direction. For controlling the direction, we are using a wiper motor to get a high torque with a low RPM. It is very precise direction control used in a high torque. Also, the same motor we are using for a braking system to same high torque and low RPM to get a precise motor control for braking system. Next, PIR sensor. A PIR sensor is used to check whether the passenger is in the vehicle or out the vehicle. Next, a LiDAR. A LiDAR which is used to create a map of an environment and is also used as a obstacle detection. After the sensor is, the system will start. Next, ultrasonic sensor. Ultrasonic sensor is used to detect the obstacle detection, which is a very important thing in our system. Next, emergency push button. Emergency push button is a manual trigger for the passengers in case of an emergency. Next, LCD display, which will replicate the destination point. Limit switch. A limit switch is used to get a precise position to stop a motor in case of an turnings or any stops. It is used also for a braking system to get a stop and start of a precise position. Next, a relay module. A relay module is acts as a electronic switch to start and stop to get a forward reverse actions for a wiper motor for a front wheel as well as also wiper as well as a braking system. Next, a Raspberry Pi. A Raspberry Pi is a main controller of our system which controls the all components with the help of a Python programming.
there is a two mechanism in our system. One is front wheel mechanism and another one is a brake system. First, the brake system. The brake system which is connected with the brake rod, which is connected to linked with the two back wheel with the drum brake, and the link will be connected with the wiper motor. The wiper motor in the setup, if any case of obstacle is detected by the use of ultrasonic or an emergency purpose, the Raspberry Pi controls the pulse, give the signal to the relay module, and the relay module will be activate the wiper motor and engage the braking system. If the obstacle is away from the system in a safe condition, the brake will be deactivated with the help of a relay module.
For the front wheel steering mechanism, we are using a chain and sprocket system. We are compared with timing belt and pulley mechanism. It will happen more damage and more slippage. And finally, we are confirmed chain and sprocket. It will have a more advantage, like there is no slippage and high torque transmission, and longer durability is used to control the direction purpose. Mechanism can handle a heavy load effectively and high torque capability. It may make it suitable for a high load condition and ensuring the reliable performance of a overtime. The wiper motor is used to control a direction purpose with the help of a relay model.
The major components. Now we are going to see the wiring connection of our system. The autonomous tri-EV, the power is given by the electrical. We are using a lead acid battery, which one battery contains of a 12 volt 100 Ah, which is connected with the series of 48 volt and 100 Ah, which satisfies the mid motor and mid motor controller. The mid motor, the all sensor wire and the three phase of the mid motor, which is connected with the mid motor controller, and the mid motor controller is the pulse signal is given by the Raspberry Pi. The Raspberry Pi is the main controller of our system, and the front wheel mechanism and the brake system, which is controlled with the help of a wiper motor, and the wiper motor which is controlled with the help of a relay module. The main if any obstacle is detected with the help of ultrasonic within the 40 centimeter, it automatically triggers the brake system with the help of a relay module, and the link will be connected with the wiper motor. The emergency switch in the wiring connection, if the emergency switch is pressed when the emergency malfunction or emergency situation, the automatic cut off the power and activates the brake. And the overall wiring circuit ensures the safety and automatically navigate the position with the effective operation.
Hello everyone, I am here to explain the process flow of our system. The first step, when they enter the vehicle, the PIR sensor will sense and send the signal to the TFT display to turn on the display. When the display on, we need to select the destination. We given 7 destinations in our campus. For example, I clicking the assembly point. If I click the assembly point, the signal will send to the Raspberry Pi, and the Raspberry Pi send the signal to the motor to run to the destination which we selected. And while running, if there is any obstacle in the surrounding within the range of 40 centimeters, the ultrasonic sensor and the LiDAR will detect and send the signal to the Raspberry Pi. If there is any obstacle in the way, the Raspberry Pi and the signal to the wiper motor to actuate the braking system. If there is no obstacle, the flow will continue and the vehicle will reach its destination. Once it reaches the destination, then we need to select for any other destination to continue.